Okay, hi. This is a quick tutorial on how to perform the VTMK or VMTK auto clip on a labeled segmentation. This is what the final result will look like, where you have clips on your artery automatically without doing too much work. Hopefully by the end, when you load it in, it should be like that, right into Synvascular, and then when you compare it to just the STL output, it should just be right on top of it with no misalignment or anything. So let's get into it. So first things first, I'm gonna clear out all of this and start from scratch. I'm gonna find my label and image. First of all, let me make sure that everything is clear. All right. So if I pull both of these in, import the label as a segmentation. All right. Uh, Start off by going to the segment editor up here. All right. So you've got a whole bunch of different things. You go to the segment editor, it should look like this. Select label, select your background, show 3D. Click this up here to make it show. You can even show the volumes by clicking that, then the eyeballs, but we don't need that right now. Let's focus in on this. Right, so this is your label. It's unclipped. You can see the ends are not clipped. Okay. What you want to do is first of all go to here. This is your extension manager, the blue sort of thing. Right here. You want to install the VTMK, or is it VMTK? I always mix them up. VMTK. You want to install that and then restart your 3D slicer. That's the very first thing. All right. That's the first thing. Once you've installed it, you close it out. You reopen. You reload the data like I just showed you. Then you'll have access to this. From here, you're going to do two things. You're first going to extract the center lines, then you're going to clip the vessel. You can't clip the vessel without extracting the center lines, so let's extract the center lines. All right. In the extract center line module, surface, click the label. Segment 1, just leave it as it is, automatic. You don't have to do anything. Endpoints, create a new point list. Click on auto detect, and these should pop up. From here, you don't want to adjust them just yet. First, you want to create new model and hit apply. Once that's done, now you can adjust where these will be. You don't have to adjust them if you don't think it's necessary. Actually, you don't even need to adjust these endpoints at all. I think these are fine. Whatever the ones that come out as they come out as, I think it's fine. You don't have to do anything else. But if you did, you want to apply first so you can get a see-through look at the center line itself. Now, you're done here. You go on to clip vessel. Surface, click label. Center line, click center line. Clip points, click endpoints. This is very important that your surface, you don't pick the center line. Make sure you pick the label or whatever STL you chose. Outputs, create a new model. Now, here's where you have a bit of freedom. You can choose to extract with the capped surface or without the capped surface. I'm going to show you how they both look. Let's first do with the capped surface. No, actually, let's do without the capped surface so you get a good look at what it looks like. It should take a few seconds. All right, now it's done. Your vessel is now clipped. without the caps, it looks like this, where there's like the ends are just cut and you can see right in them. Then you can also keep them with the cap. Now, I'll show you why this choice is important later, but all you have to know for now is that if you don't cap it now, you'll cap it later. I prefer to cap it later in the other program that we'll be importing this into Synvascular, just because it makes things easier, but you do have the option of extracting with the caps. So with the caps, they are all closed off. You can choose both. You can choose either one. Whatever you choose is fine. But I will choose without and hit apply. Alright. A few seconds again. Now you want to save. For right now, we're only worried about the output surface. But generally, in this pipeline and among the other videos that you'll see from me, you want to save your center line as well. And you want to save your center line as a VTP. Then your output, which is the focus of this video, you want to save as an STL. You can also do VTP, but I've just been doing STL just because that's what I'm familiar with. But you can do both. Then I'm going to save them inside this main folder. And you can name it with the correct. So I'll just show you how I do it. So the number of the file is 112.09966. So I will rename it as such. 112.09966 underscore centerline. So I guess this will be a two-part video. Not two-part, two birds with one stone kind of video where I do talk about how to extract the center line as well. Okay, then 112.09966. We will call this no cap or auto clipped, whatever you want to call it. I'll call it auto clipped for the sake of this video. Then save. Alright, and we're done here. You can now exit out of 3D Slicer. Then in Synvascular, I have a bunch of test files that I'm working on. Don't worry about those. As a matter of fact, I will delete all of them. Just do not worry about that. Right? But you go into your models, import your model. We're going to go to the files that we just created, the auto clipped and the center line. So the center line, you just want to move it to the appropriate folder. Don't worry about that for now. The main thing is the auto clip. So we're going to call this 112.09966 model. I think that's what I should call it. Not auto clip, but model. Model is good. Yes. Angle 50. Boom. Now you have this. So the reason I say not to use the caps, not to extract the caps in 3D Slicer, is because when you get here, you have the option to just fill your holes using that option right there. And this is much better because in some cases, when you bring in like a STL file that you just worked on, it'll normally come with a whole bunch of other parts of the vessel. This one is good. It's a clean build where it only had one, but most of the time it'll come with a few others. But if you already have the caps extracted, then it takes that a little bit more time to go and like go through each one and kind of like sniff out which one is not a cap. So that's why I like to extract or export without a cap and then filling it inside Synvascular. When you're here, now you name this wall or artery, and this is the type wall, and you'll see that all the others will just be caps. So cap, make sure that they all correspond to something. Oh, this one is cap as well. Cap, just making sure that they all exist, because in some cases they will probably be like a mistake or a blemish, and then you can name them accordingly, you know. Let me just do that really quickly with the sort of naming convention that we have. So this one will be N2. This one is D1, I believe. Yeah, that's D1. Alright, this one is an inlet. I could have just ended the video, but I'm just gonna make sure you get 100% of the detail here. This one is M1. No. N1. This one is M1. And this one is D2. And this one is your LAD. And the final one is your LCX. This is the naming convention we use. So basically, anything that's on the LAD facing down is a diagonal, so hence the name D. Anything that's coming out of, excuse me, the LAD upwards would be S. Anything that's on the LCX, this is the LCX right here, boom. Anything that's on the LCX coming down is M. Anything on the LCX that's up here is N. And anything that's around this vicinity, like the first third of the LAD is 1, or the main branch will be a 1. Anything from here going down will be like a 2, and then anything in the final sort of third will be a 3. So that's just the naming convention. So here we have 1, 2, and then 3. And then this one is a bit weird, so I just chose to call it 1 because I didn't want to have a 3 that's way up here, you know. But that's how you do it. That's how you automatically extract. Yeah, thank you for watching.